All right, welcome to the discussion for 3.5 and 3.7. There was a couple of questions asked, so we'll just dive into it. Let's take a look at 3.5, number 20. So 3.5, number 20 asks you to simplify the square root of -5 times the square root of -5. And it's very tempting to say, oh, I've got the square root of a number, square root of another number. I can call this the square root of those two numbers multiplied inside a single one. It's tempting to do that, but you cannot do that anymore. To use this property, you have to have rational numbers, and the square root of a negative value is not a rational number anymore. And so this property cannot be used, right? If you simplified this, negative times a negative goes to positive 25, and the square root would be 5, but that is a wrong answer, right? And again, it's because we have these negatives inside the root. So we have to take those out first. So we note that we have, we'll just say note here, if I have the square root of a negative number, I can pull the negative out as an I, right? Now I have the root of a rational number, and so I can use this property. So I would do that to both of these. So this negative root 5, or root -5 would become an I times the root of 5 multiplied by another I times the root of 5. The square root of 5 times the square root of 5 is the square root of 25. And then the I times I squared. We should know by now that I squared is -1, and so this simply becomes -1 times the square root of 25, which is 5, and so the answer is -5. Right? We could have guessed that, skipping all of this, by saying the square root of number multiplied by the square root of that same number is going to be that number. So it's not a surprise that we end up with -5. But again, we can't go down this road because this is not a valid property. You know, you can't multiply these two things inside a square root if they aren't rational number or real numbers to begin with. Right? All right. That was the only question on 3.5. So let's look at 3.7. And number 3. And so number 3 says, it gives us this function, x squared minus 9 over x squared. And then asks a couple of things. Okay, so it asks for the x-intercepts, right? The x-intercepts happen when y is equal to 0. Right? And so, or f of x, right? It's either y equals 0 or f of x equals 0, whichever, it doesn't matter, where I have this. It's f of x equals that function. So I'm just going to plug in a 0 for f of x. 0 equals x squared minus 9 over x squared, right? And I just have to solve for when this is equal to 0. But this x squared doesn't matter in the denominator. It sort of matters in that it removes the possibility of x being 0 as an actual 0. But if I multiply both sides by x squared, I can eliminate that. So really all I care about is this numerator, right? 0 equals x squared minus 9, which, note, is x minus 3 times x plus 3. I want to factor it this way because if 0 equals these two things multiplied, then either one of them is 0 or the other is 0. So x minus 3 is equal to 0 or x plus 3 is equal to 0. I'm kind of short on space here, but that ultimately tends us to is x is either equal to 3 or equal to -3. Right? And that's my x-intercepts, right? With x is 3 and -3, so that is to say at 3, 0, because the next intercept has y equal to 0, And the other one would be when x is -3, and so that is -3, 0, and those are my two x-intercepts. I'm going to erase all of this from here down, so if you need that, pause it, because here it goes. We're going to take a look at the next part of this problem that says find the y-intercepts. The y-intercepts happen when x is 0. And so all I have to do is plug in 0 for x's, but if I do, I get this, well, 0 squared, that's still 0, -9, so that's just a -9, but it's over a 0 squared, and that's not happening, right? Can't divide by 0, and so there are no y-intercepts, because if I try to plug in 0 for x, this thing becomes undefined, so there's no y-intercept. And I think that's an option. Yeah, one of the options is none, and that's it. All right, let's look at 5. Gives us a function where we have this f of x equals x to the 4th minus x to the 3rd minus 6x squared all over x minus 2 squared times x squared minus 1. Okay. We have that. They ask us a few things here. First thing they ask us is to find the vertical asymptotes. The vertical asymptotes occur when you have a 0 in your denominator, right? So note that I'll get a 0 in my denominator if x minus 2 is equal to 0. And so that is to say, x minus 2 equals 0. I would add 2 to both sides. That gives me x equals 2. That's one of my vertical asymptotes. The other option is when x squared minus 1 is equal to 0, but note that x squared minus 1 is x plus 1 times x minus 1. And therefore I just set each of these equal to 0. I'll skip the work here, just set x plus 1 equal to 0, solve for x, and do the same thing. And you can see pretty quick that you'll end up with positive and negative 1. And those are my vertical asymptotes, and that's all of them. It happens at 2, happens at negative 1, and then it happens at 1. Okay. The next thing that they ask is the horizontal asymptote. The horizontal asymptote happens depending on the highest power of the numerator and the denominator. So note that if I expanded out this denominator, the top would be x to the 4th plus yada yada. It doesn't really matter what comes next, I'm just going to look at this guy. So it's a 1 in front of that guy, it's just 1x to the 4th plus some lower level stuff. If I expand out x minus 2 squared, I'll get an x squared out of that. And if I multiply that x squared that I get there by the x squared that's in here, I'm going to get an x to the 4th, and because this is a 1 in front of here, and that's a 1 in front of there, there's no other numbers that will distribute in here, this is also a 1. And then plus some other junk that I don't care about, right? If the power of the numerator is the same as the power of the denominator, then there is a horizontal asymptote that is the ratio of those two numbers in front. It's the ratio of the coefficients. So in this case, I do have a horizontal asymptote, and that is at 1 divided by 1, which is 1. So my asymptote is at y equals 1. They also asked us to find the x-intercepts. So if I look for the x-intercepts here, the x-intercepts happen when y is equal to 0. And so it's 0 equals all of that. But again, we saw that we don't really need to care about the denominator. I only really care about the numerator when it's 0, as long as that 0 doesn't happen on a horizontal, or excuse me, a vertical asymptote, right? So I'm really only interested in saying 0 is equal to the numerator, x to the 4th minus x to the 3rd minus 6x squared. How do I solve this? Well, I can factor out x squared from each of these on the right. That is x squared multiplied by x squared minus x minus 6. And then this x squared minus x minus 6 is x minus 3 times x plus 2. And so this is equal to 0 when either x squared is 0, so that happens at 0. When x minus 3 is 0, so x is 3. Or when x plus 2 is equal to 0, so negative 2. And those are the three x values where I find x-intercepts, right? And so you just turn these into points, right? You would have 0, comma 0. And then you would have 3, comma 0, and then you would have negative 2, comma 0. And those are your three x-intercepts. None of those lie on the vertical asymptotes, right? Because that happened at 2, 1 at negative 1, and so we're okay. And then they ask us for probably the y-intercept, right? We can cheat because it's right there, but if we didn't see that, or if we didn't have that, we would just say that the y-intercept happens when x equals 0. And to calculate that out, I would literally just plug in 0 into everything. So 0 to the 4th minus 0 to the 3rd minus 6 times 0 over 0 minus 2, which is just negative 2 that gets squared. 0 minus 1 is just minus 1, right? But the top is 0, so it's just 0 over not 0, so it's just 0. And therefore the y-intercept is 0, 0. Good. Let's take a look at number 8 was also asked. And so I'm not going to do most of 8. I'm going to do, because 8 is very similar to number 5. But there is one thing that I want to talk about 8. So let's take a look here. F of x equals 6x squared plus 1. Over 2x squared plus 7x minus 4. Okay. We have this. You would find your x-intercepts and your y-intercepts and your vertical asymptotes all the same, just like we just did. But here, let's take a look at the horizontal asymptote. That horizontal asymptote, again, because the powers are the same, I have a second degree polynomial in the numerator and a second degree polynomial in the denominator, that it's just the ratio of those two coefficients. So it's y equals 6 over 2, which is to say y equals 3. Okay. And that's my horizontal asymptote. Now, one of the questions down below says the point where the graph crosses the horizontal asymptote. That's what we want to know here. Which you think about asymptotes as this line that you just get close to and can never touch. So it's weird that they ask you where does it cross at, because you're not supposed to cross asymptotes. But these horizontal ones you can cross in the middle, right? Or the kind of close to the zeros. If I have some asymptote, in this case it's 3, that just means whatever's happening towards the end I get closer and closer, so I might be doing something like this. But in the middle I might cross it a lot, right? In close to the zeros, close to these smaller numbers, I might cross it a few times and then the behavior kicks in where I approach it, right? And we do cross this one. It's not at a great number, but let's figure out where that is. In order to cross this asymptote, though, I have to have this. I have to have y equals 3, or I have to have f of x equals 3, which is to say 3 equals all of that junk over there, right? So let's plug that in. I'm going to need some of the space, so I'm going to erase this here. So I just plug in 3 in for my y value, my f of x, equals this, 6x squared plus 1 over 2x squared plus 7x minus 4. Right? And I have to just solve this. But I can take and multiply both sides by this denominator. Right? Over here it just cancels. Gone. That's why I did it. Over here I'll just take this 3 and distribute it through to everything. So that gives me a 6x squared plus 21x minus 12 equals, all of that's gone except I've got the 6x squared plus 1. But nice enough, this 6x squared and that 6x squared, if I try to move the x squareds to one side, I'm going to eliminate my x squareds, right? Subtract 6x squared from the left-hand side, subtract 6x squared from the right-hand side, and they're just gone. Which is nice because then it brings us down to a first degree. So all I really want to do is isolate this 21x on the left-hand side. So I will by adding 12 to both sides. So I have 21x equals 13, and then just divide by 21. X equals 13 over 21, that's the not very nice part of this, right? But then our solution is, if x is negative as 13 over 21, we were looking for when y is equal to 3, right? That's what we plugged in here. And so that point happens at 1321 and that horizontal asymptote value of 3. And that's our final solution there. Good, thank you much, and I'll see you guys next time.